Okay, so question 67 is actually very, very similar to question 63. But these guys are actually really fun to play with because you don't really need to worry too terribly much about making sure you do RNS formally. You can actually most of the time rotate these molecules in your head and instead of doing RNS, which can take a bit of time. So what I'm going to do is for 67 versus 63, I'm going to go through two of the four sub-questions. So there are sub-questions A through D for this guy. And instead of formally figuring out RNS, I'm just going to start rotating these molecules in my head and try to give you an idea of how I'm rotating them so you can kind of get in that habit. If you can rotate the molecules in your head, you actually will end up saving yourselves a lot of time on exams and quizzes and all that stuff and make things a lot easier on yourselves if you can do it this way. And fortunately, some people are really good at doing this in their head. Other people, you have to work a little bit, harder to do it. But it is one of those things that the more you try to do it, the easier it's going to be. But so going back to the question is, are these sets of molecules identical, enantiomers, diastereomers, or constitutional isomers? So obviously these, for sub-question A, they're not identical simply because even though you have the same atoms and the same regiochemistry, you have different stereochemistry. So these guys will not be identical. And because they, have the chlorine and the methyls attached to the same carbons along the five-membered ring, they're not going to be constitutional isomers because you have to think back to the definition of constitutional isomer. That means that you're going to have atoms attached at different positions along the ring. So let's say comparing this guy right here, if we had this molecule and you had the same molecule, but the only difference is that instead of this methyl group being on position 2, let's say you had it on position 3, then this molecule and this molecule would be constitutional isomers simply because you have different regiochemistry. Okay, but that's not what they're asking. So, or at least that's not the molecule that we've been asked to compare and contrast. So let's go back to what we do have. So we have these two molecules. We know that it's not going to be a constitutional and it's not going to be identical. So basically our decision-making process has been reduced down to either enantiomer or diastereomer. And you could formally do this by assigning R and S to these four chiral centers, or you can just kind of play around with rotating this molecule. So what I'm going to do is I'm going to rotate this guy. I'm going to change color just for a second. I'm going to rotate this guy, and let's see if we can rotate along the y-axis. So this is our y, and we're going to rotate this guy 180 degrees along the y. Okay, so we're going to go ahead and switch up how this guy looks. Rotate it along the y. And so if this is carbon 1, this is carbon 2, we're going to rotate along this axis. We're going to have chlorine facing this way. And instead of facing forward, it's going to end up facing backward. Okay. And for carbon 2 is also going to be rotated along this y-axis. And instead of being facing into the other room, it's going to be facing towards you. So we're going to have this guy facing towards us. And again, this is a methyl group. So methyl group here, methyl group there. Okay. And what I'm going to do is I'm going to take this guy right here, and I'm just going to copy paste, pull him down here, and go ahead and make it look pretty by adding that methyl group. So if we look at these two and pretend that we had this mirror right here, then we can ask ourselves if these two might be enantiomers. So that means you have to go back to the basic definition of the enantiomer, which is, are these non-superimposable mirror images? And if you look at this guy, you'll find that these two chlorines are not going to be mirror images of each other. If you just looked at the methyl groups are both pointing towards you. So this seems to be both of these methyls are mirror images of each other, so that seems good. But now this chlorine is facing into the board, and this chlorine is facing out towards you. So since they are not enantiomers, then what we must have are diastereomers in this case. So we have to have diastereomers between these two molecules because they're going to be non-superimposable because of the different stereochemistry, but they're also not going to be mirror images because of what we just shown right here with these two chlorines facing in opposite directions. Okay, so these two guys are going to be diastereomers. So I'm just going to abbreviate it as dias or DIAS for diastereomer. Okay, so that was pretty easy, and I didn't have to do any kind of RNS designation. So yeah. Okay, so for sub-question C, what we're going to do is play around with this a little bit differently. Instead of rotating and translating this molecule on the right, what I'm going to do is I'm going to translate and rotate this molecule on the left. So we are not restricted to just rotating on the y-axis. We can also rotate on the x. That's always something we can potentially do. We can also attempt to just keep the molecule in the same axis and rotate it in this kind of fashion, so like we're rotating it along the clock or face of a clock. So that's one possibility. So what we're going to do is I'm just going to rotate this molecule in this counterclockwise direction and see if I can get this chlorine to line up with this chlorine and this methyl to line up with this methyl, just to see if we drew a mirror plane, if we'll actually get an enantiomer or not. It would be really easy to compare and contrast if that was the case. Okay, so what I'll do is I'll just take this guy and I'm going to show what I would get if I just rotated counterclockwise. And I'm going to rotate just enough to have the chlorine that's pointing up right here point down and the methyl point up. Okay. What I'm doing is not rotating along the y-axis or the x-axis. So we're not actually going to change the orientation of the chlorine and the methyl in terms of whether it's facing out or facing into the board. So they're still going to be facing out towards you, but we're rotating it just enough to have the chlorine face down, methyl face up. So what I'll do, just to make this a little bit easier to see, is label these carbons. So this is a pink carbon, and this will be a blue carbon. And so after we completely do the rotation, what's going to happen is that this methyl group is going to be facing up, so it's going to be right here. And the chlorine is going to be facing down, so it's going to be right over here. Okay, so I'm going to move this over just a tiny little bit and fill in the blank. So the blue is attached to the methyl, so blue is methyl. Whoops. So this is going to be our methyl group. This is going to be our chlorine. Chlorine right here, methyl right here. Okay, and so I'm going to pick this molecule up and copy paste to see if we can find a plane of or a mirror plane. So this is our mirror right here. The question then is, are these two molecules mirror images of each other? And it doesn't look like they are, because although both of the methyls are on top, both of the chlorines are on bottom, the methyl in the molecule on the right is facing out towards you, and the chlorine as well is facing out towards you. If these were mirrors, you would have to have the opposite, where this methyl group is dashing into the other room, and this chlorine is also dashing into the other room. But as it is, they're wedges, so they're not going to be mirror images. Okay. So the thing here is that the enantiomer. Okay, so enantiomers are right out. So this is going to be the incorrect answer. So we're not going to have enantiomers. So it doesn't look like we're probably going to have diastereomers either. But let's just keep that in check just for the moment. The other possibility is the constitutional isomer. So we know we can't have that because we have the same regiochemistry or the same connectivity. So the constitutional is right out as well. So we're going to block that guy out. So constitutional is out, enantiomer is out. So we still have two items on the table, diastereomers or identical. Okay, so that is also a possibility. So let's try something different. If we actually took this same molecule and rotated it, what we're going to do is rotate again along the y-axis. So we're going to rotate along the y by 180. So what we'll get is the same looking molecule. Just going to copy and paste again. Copy, paste, and get rid of what we rotated. So the methyl is no longer facing left, it's going to be facing right. Same thing with the chlorine. And because we're rotating on the y-axis, We're also changing the orientation of the methyl group in terms of 3 dimensions, so instead of pointing out towards you, it's actually pointing into the board, into the other room. So this is our methyl, and this is going to be our chlorine right here. And so that these 2 carbons on the left, they're no longer blue and pink respectively. These guys are now completely white. Okay, so now at this point, it could be potentially easy to get a little frustrated because it looks like we're not really making much progress. But if you just took this and compared and contrast to this other molecule that we were originally trying to compare, it looks quite similar. And if you attempt to superimpose, you actually do have the methyl group in the same position and the chlorine in the same position. The methyl is pointing into the other room for this guy as well as the one below it, and the chlorine is also pointing into the other room for both molecules. So it looks like we don't have diastereomers, we don't have enantiomers, we don't have constitutional isomers, and in this case we actually have identical molecules. So these guys are identical. Okay, so what we're comparing and contrasting is this molecule right here and this molecule right here. Okay,